Right, hello Year 11, welcome to our second lesson. This one's going to take pretty much the same format as yesterday, so we're going to have a starter, some examples and some questions, and I'll be on Teams, so you're welcome to sort of drop in and ask me if you have any questions. So here's our quick five. You can pause the video now and then unpause it and we'll go through the answers. Okay, well, the answers then. So for the blue one, you've got circle theorem, so the angle in a semicircle is a right angle, which means that x must be 18 degrees due to angles in a triangle adding up to 180 degrees. Green one, we need to do the cube root of 27 squared, and you can do those in either order. Cube root of 27 is 3 and 3 squared is 9. This one, find the perimeter of the sector. Well, we're going to need to do 2 times pi times 8, or 16 pi, pi d, and then in fact we need to times it by, let's say, 45 out of 360. That's the same as dividing it by 8, because we have 1/8 of a circle, and to that we'll need to add on 8 and 8, which will be the two radiuses. So this first big product is the arc length, and then we've got our two radii. So in this case we end up with 2 pi plus 16 centimetres. This orangey coloured one up here, well, this one's a bit more tricky. What I would suggest that you do though is expand the two brackets on the left, the x plus 3 and the x plus 7. So I'm just going to reorder them and put the x plus a at the front, and then I'm going to times together x plus 3 and x plus 7 to get x squared plus 10x plus 21. And we know that that equals this cubic. So now we can look at it. We know that a times 21 must be 105. So therefore a needs to be 5. Again, that's all we have to worry about. You don't have to worry about checking the rest. You could do if you wanted to, and it will work for all of the values, but a should be 5 in this case. Right, and now this one, enlarge this rectangle by a scale factor -2 about the given centre. Okay, so with this one, if we were to draw a line here, we need to enlarge it by a scale factor -2. So that's twice as far the other side. So that's going to be where the new vertex is going to be. And the same with this one. So it goes across 1 and up 2. So we need to do it -2, 1, 2. So that's where the new vertex is going to be. And then I'll just fill in the rest. It's going to be twice as big. So it's going to go across here, all the way down, across, and up. So the vertices of the new rectangle are at 2, -2, 2, 4, 0, 4, and 0, -2. Okay, hopefully you got all of those. Right, so today we're going to look at this question. Hopefully this one is familiar. It's one of the questions from the mock exams we did before Christmas. You can see it was a really, really bad question. We lost 2/3 of the marks as a class. And it's solving simultaneous equations where you've got one straight line and one curve. And as I said, the mistake that quite a lot of people made was they took this top one, which is an ellipse, and they said that that's something like x minus 2y equals 3. And you can't do that, because although we've square rooted the right hand side, if you take x minus 2y and square it, that's not going to give you x squared minus 4y squared. So we need a different approach. So we'll look at an example, a couple of these, and then I've got some that you can practice. Right, so example number 1, it's not really a quadratic. In this case it's actually a linear and a circle, but same idea. So for this one, the way to do it is you need to usually substitute the linear equation into the non-linear one. So here you want to make either x or y the subject, it doesn't matter which. So let's say, for example, x equals 6 minus y, and then we'll sub it into our circle. So we get, instead of x squared, 6 minus y squared, add y squared, equals 20. Now this is just a quadratic in y, we just have to expand it and solve. So we've got 36 minus 12y plus y squared, that's my double bracket, plus the y squared that was here before, equals 20. So we've got 2y squared minus 12y plus 16 equals 0. This 16 has come from the 36, subtract 20. Now we've got a common factor of 2, so here you can divide everything by 2 and say y squared minus 6y plus 8 equals 0. And solving a quadratic, this one we can factorise, y minus 2 and y minus 4 equals 0, giving us y equals 2 and y equals 4 as our solutions for y. So our solutions for x, well, go back to the very first one. If y is 2, then x is 4. Sometimes you have to do a bit of working, subbing in, but here it's quite easy. And if y is 4, x is 2. So for these ones, to make it easy to mark, we're going to give them as coordinates. So the first one, let's say this one, is 2, 4. Remember, with a coordinate to give x first and y second. And then the second one, x first, y second, is 4, 2. So that's the first one done. So what you've actually got there is you've got a circle and a straight line. And the straight line intersects it at these 2 points. So second example is this one. This time it is a linear and a quadratic. You've got a straight line and a quadratic equation. This one's actually a bit easier to solve because in this case both of them are equal to y. So in this case what you can do, because we haven't got a y squared here, is you can just say, actually, you can just sub the first one straight into the second one. So where we did have y, we know that y is x minus 5, and that equals x squared minus 5x minus 12. And now we can solve it. So 0 equals x squared minus 6x minus 7. So I've subtracted x from both sides, and I've added 5 to both sides. And again, this one's going to factorise to x subtract 7 and x plus 1. So my solutions are x equals 7 and x equals minus 1. So again, if we go back to the first one, when x is 7, we know that y equals 7 minus 5, that's x minus 5, which is 2. And here y is minus 1 minus 5 minus 6. So if we give them as coordinates 7, 2 and minus 1 minus 6. There we go. And graphically that would represent you've got your quadratic and you've got your straight line and it's intersected at minus 1 minus 6 and 7, 2. Okay, so now there's some for you to have a go at, just like this, nice and easy, I hope, and see what you can do, and we'll have the answers in a minute. So these are the questions. There's 8 fairly standard ones, and then at the bottom, question 9 is a slightly longer one, where I've given you some information about the circle and the straight line, but I haven't explicitly given you their equations. So see what you can do with this. Can I ask that you finish with 5 or 10 minutes left, so that you have time to mark it, and then there's actually one more little bit after this. Okay, so please make sure you finish maybe with 10 minutes to go, and then go from there. So you can pause this and we'll do the answers in a sec. Okay, and here's the answers. You can just pause this video and read them all off. There wasn't really anything too crazy with them. With question 9, the circle is x squared plus y squared equals 9. and the straight line has gradient 2 and y-intercept 3. So y equals 2x plus 3, and then you could solve it in the same way, giving these 2 points. Okay, the last thing, this is quite nice. This is maybe the one good thing about lockdown, is we can incorporate graphical methods a bit more into what we're doing, because I'm going to ask everybody in here to use Desmos for these questions. So this one says solve using a graphical method these simultaneous equations. So a graphical method means using a graph. So if you go to Desmos and you type in this equation, and then you press the little plus in the top left and you type in this one, then you will find that you have a circle and a straight line, and you can see on the graph where they intersect. So I've done that, and here's mine. There we go. So there's my circle with radius 4 and my straight line, and you can see where they intersect. If you're not sure, you can click on the point and it will show you the coordinates. So here you can see then the answer to this one, if we give them maybe to two significant figures, is minus 1.6 minus 3.7 is this point, and then this point here is going to be 2.0 and 3.5. So that's my solution. Nice and quick when you do it on Desmos. So the great thing about a graphical method is you can do it with far more complicated equations as well. So the last thing I want you to do is I want you to have a go at these three. These are some slightly more unusual equations, especially number 12. I think you'll like that one. So if you can go onto Desmos, type in both equations, and then find where the two functions intersect. Each of them will have two solutions, and if you can try and give them to two significant figures, that would be good. So you can pause this now and we'll finish with the answers. Right, so here's my three screenshots from Desmos. So the first one, we've got this sort of squircle and a straight line, and I read off that the answers were, for this one here, minus 1.4 and minus 1.9, and for this one 1.4 and 1.9. Nice bit of symmetry to that one. Number 11, you've got a quadratic parabola and then this slightly more strange curve. So this one, the two intersects were at minus 1.8 and 0.69, and this one here was 1.5 and minus 1.6. I think this one's minus 0.69 as well, sorry about that. And then number 12, really nice one, because you've got this heart-shaped function, which is the first one. You can see that you've got two intersections, one here and one here. So this one is minus 0.5 and 1.2, 1.2, and this one over here is 0.42 and minus 0.67. Great. So I hope you had some success with these questions. Remember, the whole point of doing these is because of this. And I hope, if we have a look at a question like this again, we'll have a bit more success with it. So hopefully that will work. And that's it. I think we've got one more lesson this week, and in that lesson I'll probably set you, as part of it, a Dr. Frost task, where I'll get you to practice a couple of the topics we've looked at in these first two lessons, just so I can sort of see what you've been able to do. But that's it. Thanks a lot, and I will talk to you again soon. Bye-bye.